we've been building houses the same way for well over 100 years. I mean, you can go back 1,000+ years and seeing people build, housing structures out of flat sawn or flat cut wood. Some of these structures were like historic sites, right? They've got a very good advantage. They've been squeezing water from a rock for well over the last 100 years. This new technology that we're doing, 3D printed concrete houses, is still in its infancy. And we're really at the edge of competing with them on price, and we're beyond them at that same price with quality and performance. So one of the interesting things that's developed over the course of the last 15 years within 3D concrete printing is the variation of the machines that are actually doing the work. It's generally kind of 3 segments of machine, right? So you've got some of the cool robotic arm machines. They're repurposing industrial robots, like putting on a print head and figuring out how to move that nozzle through space on a robot arm to deposit concrete into later. All of these have advantages, disadvantages. The second type of machine that's typically doing 3D printing construction is very similar to a robot arm, but it'd be more of a boom arm, right? So it reaches out much further, it's typically brought to site, and the advantages of it is it's got a decent range when compared to a robot. It has okay resolution, but if you imagine, if you were trying to deposit icing on a cake and you were holding it really close to you, you have a lot of control. This is more akin to having that bag of icing on a pole, right? You can reach really far with it, but you kind of lose a little bit of that precision. It gets to be a little bit harder. And then you go over to the third category. That's where most of our technology and time is spent at Printed. It's a gantry style. There's kind of 2 categories there. One like ours with 4 towers, a big gantry. It's a large machine. We're typically trying to fit around the footprint of a house. The advantages of it is we're able to move that nozzle through the space with really good control. Right? So it takes a little bit more time to set up, but once we're set up, we're able to print, keep rolling with printing without a whole bunch of moving and moving of a robot arm per se, but we get really good precision. And then we can also do things to the print head itself, where we can actually rotate the nozzle and introduce some different elements that we're working on that are really kind of cool. But at Printed, we think that gives us a very economical, really robust system, very approachable to more and more people, so that when it's deployed at scale, someone who has no experience in robotics, no experience in how to actually print a house, within a relatively short amount of time, they can kind of get their head around it. They understand what's going on, and they don't need some technician to come out and diagnose an overly complicated robot arm. They have their own merits, but we think what we're doing with a gantry style printer is working out really well.